So, how many programming languages can you name? 5, 10, 15? Well, there are quite a lot of them, guys. A few examples are here. You've got the basics, Java, C++, PHP, but that's not all. There's quite a few more than that. You've got things like assembly language, COBOL, Python. You've got Prolog, you've got procedural, you've got Smalltalk, which is a very, very early language. This is how computer programs are written and coded. They all have certain things in common. The ones you need to care about for GCSE all have their own IDE. IDE stands for an Integrated Development Environment. What's that? Well, it's a nice section of windows and tools to build your program and to let you add features to it. Some, like the Visual Basic one you see here, are quite designed for clicking, pointing, dragging, and being very, very simple. Others, like the Python IDE, which is known as idle, is far more simple and just has pure code. But it also has features inside to debug or spot errors in your code, and it can also test your program out for you. The reason Python calls its IDE, Integrated Development Environment, idle is because the man who invented Python was a massive Monty Python fan, and one of the actors in the legendary 70s TV show Monty Python was Eric Idle. So, that's the history of that little idea. Now, computers always start with a programming language. You write the program in programming language. This is a logical, sensible language, and the computer can't understand a word of it because it's far too logical. But because you have written it in a logical language, it can be compiled, that is, translated into assembly code. Assembly code is the stuff you can see on the top right, which is half or slightly understandable to humans. The computer, the operating system, can understand this, and it will then translate this into machine code, which is zeros and ones, as you see in the bottom right-hand corner. This is pretty much unintelligible to any human beings who are sane. So, that's how languages work. You write the code, they translate the code into assembly code, and then assembly code to machine code. Nice, simple, and clear. So, all languages, guys, have algorithms. Algorithms are lists of instructions to be carried out in the language. Most languages have several features built into them, which should be clear in any language. Can you think of a few? Well, a few could be selection or if. If this is right, turn right. If this is left, turn left. Variables, integers, strings, booleans. Loops to repeat the same thing over again. Function, so you can call the same pattern of code again and again and again. And arrays or lists, where you can store lots of data sequentially. These can be used in pseudocode. What is pseudocode? Well, pseudocode is writing out what you want the computer to do in plain English. You can see some pseudocode in front of you right here. So, next, how do you design your program? One way is pseudocode, the other way is flowcharts, which are an even simpler way of doing pseudocode. Now, you probably saw the basic ones of these when you were at primary school. You were given symbols like these, and you were told this is how you draw out instructions. So the start or the end is a rectangle with rounded ends. A square box says a step you have to do or take. Draw a diamond or a slightly angled square, and you have to make a decision, yes or no. Yes, no. And that's an indecision a computer can take as well. Do you want to get information from your user or give information back to your user? Well, for that, we use a parallelogram or a slightly slanted rectangle. Anything you want to store the data, you use a curved rectangle, as the picture shows, and say you want to delay or pause the program for 5 seconds or 2 seconds or any time you wish, you use the bullet-shaped delay tag. How do these look? In real life though, how do you design a program like this? Well, here is an example. For code, you can see two ovals for start and end. So the program starts there and ends there. A parallelogram means the user has got to give us some information, and it's asking for us to input X and Y. Then, once you've got those two numbers, the next part of the program is to add X and Y. We don't need user input or data for this, so it's just a plain rectangle. Then, we want to display the answer. Now, inputs and outputs go in what? Yep, you're right, it's the parallelogram. So you put in there, display sum. And that is then nice and easy. A second piece of code is here. The second piece of code, this one, try it out in a language of your choice. Programming languages use common features, so should be achievable in any programming language you like. Just pause here while you try it. The benefit of a programming language and design is if you design the code before you start, you come into far fewer errors and it makes far greater sense to you and to your user. I hope this has reminded you about pseudocode, why we have programming languages and flowcharts. Good luck in your exams. Best of British luck. Adios.